Okay, at this point, we now have a fully functional DAG engine. That's fantastic. But are we finished? No. If we think back to when this challenge was first presented with Knowledge Review 7, you were asked to create two things: the DAG engine itself, and then a command line interface that would allow a user to easily use your DAG engine without, of course, having to go into it and add code. I mean, think about it. Right now, how do we create nodes? Well, we simply add the appropriate code within our application, recompile our application, and execute it. And it's like, hey, we've created a new transform node or a new light. All right, and we've just parented that guy. That's fantastic. But is this really a usable application if we handed it to someone else? Of course not. We'd have to hand them the source code, and they would need to go in there and code each of the transform nodes, shape nodes, etc. themselves. So it's not a usable application at all. And that is why we need an interface. It would be great to be able to hand our application to a user and say, go ahead and generate your own scene hierarchy. And at that point, they can sit down and they can start using a series of predefined commands. And we talked about those predefined commands when we introduced you to this challenge. Remember, we said things like sphere, light, what else we have? Parent, group, rename, delete, etc. You know, if they knew these commands, they could sit behind your application and begin creating a series of nodes and create a scene hierarchy and, well, manage the nodes. But they need this interface in place. So in this video, what we're going to do is start talking about the architecture behind this user interface. Now, if you do not yet have an interface and at any point during this video inspiration strikes, please stop the video and try to implement it yourself, because of course you're going to pick up that warm fuzzy feeling if you do successfully complete the challenge. But don't worry, if you feel stuck or a bit confused, just keep following along with the video. We'll see if we can make things as clear as possible. Now, the first thing we'd like to do is give you a hint about how you may want to work with the data that gets input by the user. We're going to talk about arrays for just a second. Now, we saw arrays all the way back in the Hyperion project, back in Volume 1 of the XNA Xtreme class. We have yet had that official lesson on arrays. That's coming up in a later volume of the XNA class. But let's go ahead and give you a quick peek at how we can go about using a string array, and perhaps that might have been the only brick wall in your way, and with that behind you, you might be able to go out and complete this whole command line interface yourself. So obviously, if a user sits down behind your application and types something like parent sphere 1 to sphere 2 and hits enter, your application needs to break this down into the appropriate command and any and all arguments that are sent in. Well, how do we do this? Well, first of all, we know how we can get the data. We can just simply do a console.readLine. Now we have the line itself that the user just typed right before hitting the enter key. But how do we break this down? Well, what we can do is we can use what is called a string array. Now, we've all seen the use of strings. If we come in here and say string and then name, we can conceptually look at it like this: a box, a place in memory called name that we can store information in. So if I was to turn around and say name equals Bob, Bob would then be held in this memory location. And of course, I'm just keeping this as simplistic as possible. But in this particular case, we're sending in parent sphere 1, sphere 2. It's a bit more sophisticated. We need to break these things down so that we can work with them on an individual basis. How would we go about doing that? Well, we could use this string array that I keep mentioning, which would look like this. So string array, so open and closing square bracket, and then we can give it a name. Let's just call it arguments. Okay, so there we go, string array arguments. But what are we going to put into it? Well, let's pretend that we have, you know what, let's do this. We've got name up here. Let's say name. So I could say equals name, but watch what I'm about to do. Let's say that name is holding this in it, this whole line. So name is holding parent space sphere 1 space sphere 2. Now, name is a string. String has a whole bunch of different methods associated with them. One of the methods that we can take advantage of is the split method. So if I said name dot split, I can tell the method to split apart all of the words on a particular character. So let's give it the character. What if I said to split on a space? So I did an open quote or a single quote, a space, a closing single quote, and wrap it up by closing off my parentheses and my terminator. What does this look like? Well, arguments looks a bit different than name did above. Name right here was represented with just a single box, right? Let's check out what arguments looks like. So there's arguments. And we'll start it out with a box. So far it looks just like name. Now what's going to go in here? Well, check this out. We have said split apart the contents of name based on a space. Okay, so use the space character. So the very first thing we're going to get is parent. We're going to get a couple more boxes too. We're going to get sphere 1. And we're going to get sphere 2. We've lost all of our spaces. We've got parent, sphere 1, and sphere 2 broke up into their own boxes. But now how do we go about addressing these guys or using these guys as they're now, sitting there as an individual text? Simple. Inside of arguments, we can talk to each element of the arguments array. All of these guys have, well, it's just like a list. They all have an index. Starts at 0 and increments from there. So you can look at our arrays as being very similar to lists. Except with lists, we could say, if we had a list of arguments, we could say arguments.count. But in this case, we've got an array, so instead of saying .count, we could say .length. So there are definitely some differences between a true list and an array, but they are similar looking and feeling as well. So in this particular case, if we wanted to, we could turn around right now and make sure that we actually had something sent in. Take a look at this. If I wanted to, I could say if arguments .length is greater than 0. Check that out. It's kind of like with lists. You would say .count if that's greater than 0. But here we're saying .length. If it's greater than 0, that means we have at least one thing inside the arguments array. And for us to process any sort of command, we would need to have at least the command itself, because some commands aren't going to require any arguments, such as the command clear or exit if we wanted to clear our screen, or exit out of the application. They don't need any parameters associated with them. But a command, you have to have at least one thing, and that one thing is the command itself. Now, with this piece of information, how could we go about accessing something inside of it? Well, at any point, like if I wanted to say console and write out what the command is, I could come in here and say, so again, I'm pretending that these two slash marks are console.writeLine. And I could say write out arguments sub-0. So if I said write out console.writeLine, arguments sub-0, what am I doing? I am writing out what is in index 0 or element 0, which is parent. If I said write out console.writeLine, arguments sub-2, what am I doing? I am saying 2. Here's our 2. So what would we write out? Sphere 2. So this is a very basic overview of working with an array. Really simple stuff. The only thing you're really going to need to know is how to use the split method. So again, it's your string variable's name We're going to use line because, well, after all, what is the command? The method is readLine. And so we'll just call the variable itself line. We'll populate line with whatever we read that the user just typed in and hit enter. And then we say line.split and split on a space, which is represented with a single quote, a space, and a single quote. Simple enough. And then, so you need to understand how to use the split method. Then you need to know how to use .length. And .length is just how many elements do we have in the array. Simple enough. And then to gain access to each of the elements, it's just a matter of referring to the variable's name. In this case, it's arguments, open square bracket, and then whichever element you want to look at. Element 0, in our case, is always going to be the command. Then element 1 would be the first parameter. Element 2 would be the second parameter, so on and so forth. This means that we could quickly set up a very sophisticated command processing system that would allow us to put in all sorts of arguments, and we can easily loop through all of these arguments and perform multiple complex tasks all at one time. Like if we were to say group, or parent, sphere 1, sphere 2, sphere 3, sphere 4, sphere 5. That means take 1, 2, 3, 4 and parent them all to sphere 5. If you want to set your command processing system up to work that way, that's fine. Go for it. Now, in this particular case, we're going to try to keep things as simple as possible so that everyone understands the concept, the basic foundation of building this command processing system. Okay, so at this point, this has been your big hint to how to work with a simple string and split it up based off that space character. So if this gives you a little bit of inspiration on how you can handle working with your input line, go for it. Go ahead and stop the video right here and see what you can put together. Okay, I'll pretend everybody just came back and joined me, or perhaps you just sat through the silence real quick because you've already got all this. That's fantastic. The next thing we need to do is start talking about what kind of architecture do we want to employ. There are a few ways that we can go about this. We can use if statements. That's going to be horrible. We could say if argument sub 0 equals clear, then do this. Else if argument 0 equals exit, then do this. Else if, you see what I'm saying? We could go on and on and on. Messy. Okay? What else can we do? How about a switch statement? Ooh, that's a little bit better. Switch case. So we can say switch on argument 0. Then we could say case it's this, do this. Case it's that, do that. Case it might be this, do this. And so on and so forth. Not bad. As a matter of fact, that's exactly what we used back in the Hyperion project. That's not what we're looking for here. Though I bet you a lot of the people out there that went through with this project employed the switch case statement. How about this? What if we put to good use all of the object-oriented techniques we've been picking up over the last handful of videos, the last 2 sections. So the object-oriented approach. With that, perhaps we could take all of our commands and break them down into classes. That way we can isolate all of the code for each command in their own class, making it very easy to work on everything. Sounds like a good idea. But what I want to do is spend just a minute and focus on the switch and the object-oriented approach. Let's go ahead and bring up another whiteboard real quick, and I'll just jump back and forth. All right, new whiteboard. Before we even get the whole switch or object-oriented approach going, we've got to back up yet another step. How are we going to get input from our user? We almost need to treat our little application like a game. It's almost like we need a game loop. We need a loop that's just sitting there waiting on a user to input some sort of command and possibly parameters, and then act on it, and then go back to waiting for the user to enter another command until finally the user exits out. So let's see if we can draw this out. Back in main, what I'd like to have is going to be something like this. Here's our loop. And this is back in our main method. And of course, what are we doing? We're going to be grabbing a line. Now, once we get a line, we need to send that line somewhere to be processed. We don't want to stay right there inside of main. That's not a very clean way to do everything. How about this? What if we create a command manager class? Let's think about that for a second. Inside the command manager class, we could basically put every piece of functionality that dealt with getting a command processed. Okay, not the commands themselves, but calling upon the specific command to process. Or if you want to, you could even put all the meat to each of the commands themselves in there. The whole idea is the command manager is going to manage commands. So let's start out by drawing some sort of puffy cloud, because right now it's just all conceptual ideas. Ooh, that's a rough looking cloud. And how about, this is all, I'll just put it over here, the command manager. Fantastic. So this big puffy cloud, let's say that this is a method. So inside the command manager, this will be, I don't know what makes sense. Process command makes sense. So this will be our process. So that's process command. And that is process command. You just have to believe me. Okay? I'll fix my R. Good enough. Okay, so process command will handle bringing in whatever was just typed out at the interface, the command line, to type it in, hit enter, then we'll call upon the command manager's process command method, and we'll send that line in to be processed. Now, obviously, the first thing we can do is split apart the command and take that very first element. Remember, arguments sub-0, first index. And that's our command. And then we can figure out what command we need to execute. So far, so good. It's pretty simple. Now let's think about command manager itself. We don't need to instantiate command manager. Wouldn't make sense, would it, Logan?
No, I mean, the command manager is just that it is the command manager, which implies that there is only one.
Exactly. So that tells me that it would be a fantastic idea to make sure that our command manager was static. Okay, so now we have only one command manager. Perfect. Which means our process command, of course, would be a static method. So gaining access to it from inside main would simply be a matter of saying command manager dot process command. And we'll set process command up so that it takes in a single parameter, and that single parameter will be a string. So we could actually finish this off by saying that process command is going to bring in a string called something like line. So there is our parameter list. Of course, all caps, but we know we won't be using all caps when we start typing out the code. All right, so the next question is, what are we going to do inside this fuzzy cloud? What is process command going to actually do? This is where we could put to use if statements, the switch statement, or start utilizing the object-oriented approach. Let's take just a second and look at the switch statement. We did this all the way back in the Hyperion project. So what would it look like here? Let's jump back over here to this area. And bring our focus back down here for just a second. And how about I just come in here and make a little bit of room, and we'll take a real quick peek at what it would look like. So just clearing a little bit of room real quick. And we'll come down here. And just in case I decide to go on and on with typing out code on the whiteboard. All right, so at this point, we know that we've said if argument's length is greater than 0, that means we at least have one command in there. What would we do? Well, we'd do a simple switch. And then switch off of what? So here's where the interesting piece comes in. Switch off of the arguments, arguments sub-0, because that's our command, and that's what we're interested in switching off of. Let's close this off. All right, and then we'll go ahead and block this in. And at this point, we would have a series of cases, and each case would represent its own command. So we'd have something like case. So in case they typed in, how about we do clear? So in case it was clear, colon, and then we'd do whatever we needed to, and then end it all off with break. And then we could say case. They typed in exit, and colon, and again, whatever we needed it to, and finally break. And let's just go ahead and end it off right here, and end off our if statement, keeping this as simple as possible. But here you go. We've now called upon this little process command method. I'm just kind of showing you the guts of it right here. And the first thing we've done is we've split apart the line that's come in into a string array. Now we've made sure that we do indeed have a command. And then we're employing the switch methodology for our command processing in this scenario, where we're saying switch based off of arguments sub-0. So whatever is being stored in, right here, the command itself. And then if it's clear, if it's exit or whatever, you can see that this could end up going on and on and on and on, and it could become quite messy to manage. As a matter of fact, Logan, it'll only take us a minute. Let's put this to use. Let's show them this approach real quick.
Sure. Let's jump over into Visual Studio and take a look at what we would need to implement that.
See, I think it's a good idea to go ahead and show them this, and here's why. Because we're not going to change the loop architecture. The loop still needs to stay the same, right?
Right.
So we can just go from, and we're going to have a command manager, so we can use this point in time to set up a command manager class. Now let me remind everybody that's watching, at this point, feel free to pause or stop the video and try this yourself if you are having some sort of inspiration strike. Don't just sit here and watch us work our way through it. If you think you can do this, if you do it. Okay, so Logan, the first thing we probably need to do is go ahead and create that command manager class itself.
Sure. And before we create that class, I'm actually going to group everything relating to commands into its own subfolder within the project.
Slick idea. I like it.
So I'm actually going to make a folder underneath the classes folder, and I'm going to call this new folder commands. So anything dealing with commands can be placed here.
Okay.
The first thing will, of course, be the new command manager class. So we've got command manager.
Okay. And let's go ahead and clean up that namespace a little bit.
All right, let's take this all back so that everything is in knr7.dag.
And, of course, we'll make this a static class because we only need one command manager. All right, fantastic. Now, before we do anything else with this, let's go ahead and get our infrastructure in place back in the main method that will call upon the command manager.
All right. Let me jump in below some of our test lines where we had a few nodes in the scene and put together this input loop that we were talking about.
And since, of course, we have these embedded lines of code right now that will create a sphere node, a light node, and do some grouping and show all. Every time we run our application, don't forget, we're already going to get something echoed out to the screen. So it'll be right underneath that will then be taking in input.
Okay. Now, for this input loop, the way I'm going to do this is to create a very small infinite loop, since we don't have any kind of exit condition defined.
Right.
We don't have any kind of exit command yet.
That's right.
So I'll begin by making a while loop, and I'll loop as long as, well, true.
So now we're looping forever, so it's going to be up to the user at this point to simply hit the X button in the upper right hand of the console window.
All right. Now that we've got an infinite loop set up, we can look at taking actual input in from the console.
Okay.
Which means we would do that by doing something like console.readLine.
Of course, we need to rather store this in something or send this in something. So let's set something up that we can send it to. So let's jump back over to the command manager class, and let's go ahead and put that process command method in here.
Okay. Now, of course, this method is obviously going to need to be static because we're in a static class. It will also need to be public because we need to access it from outside of this class.
That's right.
So this will be a public static method. It will be void because we're not returning anything. And we'll call this process command.
And as I said back over on the whiteboard, it needs to take in a single parameter of type string.
All right. So we've got our string parameter, and we'll call this line because we're taking in a line of input.
Okay. All right, good enough. Now let's go ahead and jump back over to our loop. Now let's take this read line data and send it over there. So let's put it all on one line.
Okay. So we're going to access the command manager.
Okay.
And we're going to tell it to process a command.
Okay.
And the command that we want to process is the line of input we have just received from the read line.
Beautiful. Now, the nature of the read line method will simply halt execution of your application until the enter key is pressed. So we will be held up at our console window waiting for the user to type something in and hit enter. When that occurs, the process command will be called and that information will be sent to process command. And once we're done there, we'll return back to our infinite while loop, which means we'll simply loop back into the scenario of waiting for somebody to type something in at the read line method once again. All right, very good. So let's go ahead and jump back over to the command manager. And now from inside here, let's start out by simply showing them that we are indeed receiving some data into the process command. So how about we do a console.writeLine and write out what is being stored in the line parameter.
Okay. So console.writeLine, where we write out line, and there we go.
Beautiful. So let's go ahead and jump back over to main real quick. And at this point, you no longer need that read line down below. So let's take that guy out. Because that, remember before, was just simply halting execution so that we could see the results of our transform node.showAll, etc. Now, we're held up by this infinite loop. So let's go ahead and run the application. Of course, we're going to see some information spit out to our console because of the commands that we've left in place. But now we have our flashing cursor, which is being generated by the console.readLine method, which is inside our while loop. At this point, if Logan types in anything at all and hits enter, it's going to echo that information back out to the console, and that will let us know that the process command method was indeed hit, and we did indeed send the right information over. So here he goes. He's going to hit enter, and look at that. It was sent over. So he types in sphere, hits enter, sphere gets echoed out, light gets echoed out. So far, so good. Let's go ahead and close the console window now. And let's prove that we can split things up in this string array. So let's jump back over to the command manager. And now let's go ahead and do a string array called arguments and store the split up line into it.
Okay. So we need to begin with a string array. We're going to call it arguments. And we are going to turn around and immediately initialize it to the result of line.split, where we feed split the character space, so that we split up based on spaces, so we get the individual words.
Okay.
And then that should be it, terminator, and we should be storing that in arguments.
So now, here's what I want to do. Let's go ahead and do a write line. And since we saw that length lets us know how many elements are inside the array, let's go ahead and just write line arguments.length so that we can see that we are indeed splitting it up into the appropriate number of elements based on what you send into it.
Okay. So instead we'll look at arguments.length, and we'll echo that value out by using the read line.
Awesome. So let's go ahead and run. So now at this point, if Logan just types in sphere and hits enter, it's going to echo out 1 because he's only typed in one thing. There is no two different sections of text separated by a space. But if Logan was to type in parent sphere light, so now he's saying parent the sphere to the light. We have 3 different pieces of text separated by spaces. So we should see 3 echoed out in our console. And there's a 3. Perfect. So let's try one more thing. Just type in hello space world, and that should echo out too. Awesome. So this is fantastic. We now know that we are splitting up our input into each of their own elements inside a string array that we can now act upon. So let's go ahead and close that down. And let's start, we can go ahead and take out that console.writeLine. Let's see if we can actually put a very simple command system in based off the switch command. So we'll go ahead and do the if arguments.length is greater than 0, like I demonstrated over on the whiteboard.
Let's make sure we have an actual command to look at.
That's right. Now inside here, let's go ahead and start our switch, and we'll switch off arguments sub 0. Because the command is always going to be the first thing. Now let's go and do a case. So let's say in case it's clear. We'll pick on the clear command because that's very easy to implement.
All right, so we've got a case for clear.
And then with this, just do a console.clear.
And we'll say console clear, so that is the action to be performed when clear is entered.
Of course, we'll have to break out. All right, perfect. So here we are. We actually have a command system in place, and right now we are respecting a single command, the command clear. So go ahead and run it real fast. And there's some stuff echoed out. Now type in, just hit enter. Nothing happens at all. Type in hello. Well, that's going to do exactly what it's supposed to do because we don't have any sort of handling for commands that don't exist at the moment. Type in clear, though. The clear command did indeed work. So you can see already that we're going to need to do some sort of error checking. What happens if they just, hit enter? Or what happens if they enter a command that does not exist or give too many arguments, etc.? Well, let me go ahead and warn you now. We are trying to keep this command management system as simple as possible, once again, just to get across the concept of building one. So we're not going to go real deep into error checking. We will do basic error checking, and you guys are going to get the idea how to go about doing it. And so feel free to implement a stronger error checking system into your own DAG application. Okay, so now that we've seen the switch case in action, let's go ahead and close that window, Logan. Let's jump back over to the whiteboard. Was there anything else that you want to do there?
No, I think
Okay.
that's demonstrated quite clearly.
All right, very cool. So that's using this very simple switch case method. But I had said that we could use an object-oriented approach. Since we've learned all of these really cool object-oriented things, how would we go about doing that? Well, let's jump back up here to this particular whiteboard and draw it out. What if we start out with a command class? So let's go ahead and bring focus back for our pen as well. There we go. So let's say that we had a class called command. And the command class, of course, it's not going to be the end-all for a particular command. It's going to be the start of any command. Basically what I'm saying is every single command that we create will derive from this command class. So we'll extend this command class into our final classes. Why do we want to do that? Well, this is where we can put some of our basic type of functionality in fields, etc. Anything that we want to be common throughout every single command, we'd want to put it here. So what would be one thing for sure that every command would need to know how to do? Process. It would need to know how to handle its own processing. So what if we were to implement a process? Let's go ahead and just do that real quick. So a process method. But this process method, what if we wanted it to be virtual in nature? That makes sense, because every command that was derived from this class could overwrite the process command, giving it the implementation required for that particular command. So now we can extend the command class into a series of fully defined commands, if you will. So let's say that this was like our clear command. So now here we are with a clear class, or a command clear class, depending on whatever we decide to call it. And we have inherited the process method, but it's virtual. So inside this class, we can overwrite it, giving it the appropriate implementation. So far, so good. So let's go ahead and create just a few more of these real quick. See if I can keep my writing relatively neat. So let's say that this one was perhaps something like exit. Go ahead and create another one. Maybe this could be our ls command. How about, let's create an actual object. So how about we had a sphere command, which we're actually going to handle this in a very interesting way. You'll see later. All right, so each of these commands would be derived from this base command class. Meaning that they all inherit that process method. All right, now, every command must have a process method. That's a contract that we're going to put in place between the command manager and all of these classes. So right now, by having the process method as virtual, we do not have to provide an implementation for the process method in any of these classes, do we, Logan?
Right. Since we're required to put an implementation into command itself, and a further implementation or an override is not required in any of the descendant classes.
So this could be a problem. We're not enforcing a contract between our command manager and these classes where we are guaranteeing that each of these classes will provide an actual implementation of process. So we could make the process command, instead of it being virtual, we could make it abstract, correct?
Right, and this would afford us two things. One, we would not have to provide an implementation inside of command itself, which is convenient because in command we don't know what a specific command is going to do. It's generic, meaning that we don't know what the implementation will be yet. So making it abstract would allow us to avoid implementing it in command. Also, it would require that an implementation be provided in any descendant class.
That's right.
This enforces the idea of a command and that anything that extends command is in fact a command and does something meaningful with the process method.
That's right. So now that we have these classes, let's go ahead and put that fuzzy cloud back in place.
as there's going to be all sorts of great things to go inside our process command fuzzy cloud. But in this whole thing is just a concept, if you will. So I'm just trying to give kind of a visual overview of the approach that we are going to take for creating a very simplistic object-oriented system. All right, so inside this process command, so this will be process command. We're going to take in that line, and then we're going to split apart or break apart that line so that we have the command and all of the arguments held in their own elements of an array. Then we're going to make sure that we have indeed received at least a command. And then what are we going to do? Well, let's just say that inside the command manager itself, we create, and I'm just going to draw it inside the process command just to kind of keep everything a little bit more focused here. But let's just say in the command manager, we have a static list of commands. How cool is that? Because now, when we call upon process command, and we send that line in, and then we split that line apart, and we pull the command out, we now can loop through a list of commands to find one. Now, what am I talking about? List of commands? This doesn't make sense. Check this out. What if we were to instantiate each of the command classes when the application first ran, and we held a reference to each of these commands inside this list? Here's what I'm talking about. Let me see if I can draw this out. So we have clear, exit, ls, now let's fix that a little bit, and sphere. So check this out. Again, we instantiate, boy, these are going to be rough looking lines, but everybody will get the idea. We instantiate each of these classes. I'm having to draw sideways, guys, so bear with me. And we reference them from inside the list. Ah, beautiful. Okay. Now, one instance of each class exists on the heap. Simple enough. Each of these instances have a process method that contains the appropriate implementation for what the command should do. When we send in a command, such as, let's say you typed sphere, when we get inside a process command, we'll get sphere extracted out, of course, and then we can loop through this static list of commands looking for the word sphere. Basically, we can register, if you want to look at it that way, it's going to be the terminology we're going to use, the word sphere, the textual word sphere, to an actual object. Then, once we go through and we find, in this case, here we go. Of course, let me see if I can straighten up my board and draw that a little bit better. There we go. We find that particular piece of text. We now know the association is between that text and this instantiation of the sphere class. So this command or this object. So now we can call upon this object's dot process. Now we're over here inside the sphere object. It can handle processing. Now when we call upon it, we can go ahead and send our arguments that we brought in over to it. So basically we could say that all commands are going to take in an array themselves. We just pass all the arguments over there, and then each command can determine itself how it wants to deal with any arguments, if it needs to work with arguments. The nifty thing about this system is, watch this. I just decided I need to add a new command. I add the command in. Of course, as we have seen, the command is derived from the command class. Now, just creating the class, that's not all we need to do, because just by creating it, it's not going to work. We must come in and register that class. So let's say that particular command I just added was parent. We would have to add parent into our into our commands static list.
Right, that means we would have to instantiate it. We'd have to place it into that list and associate it with the appropriate word. In this case, the word or the text parent.
That's right. So here we are. We're going to call this registering. So we have just registered the parent command, which, as Logan just said, that involves instantiating the parent class and then making the association. So that then if we were to loop through our list of commands and find parent, if that's what we sent in, we would then call upon that instantiation's process method. And that is where we'd have all the code for handling parents. And since the process method will take in the arguments array, then we can simply break apart and say, all right, do we have an element 1 and an element 2? If yes, then we have what we need to parent a child to a parent. Let's do it. Simple enough. Now, let's make sure that command returns a string. This is where each command could simply return back, hey, I successfully created sphere 1, or whatever. Or if the command itself fails for whatever reason, such as we said parent, but we didn't send in any arguments. Well, the parent command will get called because of the way that the process command method works, but we haven't sent anything over here to the parent object. So inside the parent object, it needs to take a look at its arguments array, what was passed into it, and say, hey, we didn't receive anything, so we can return back a string that says 2 nodes are required, a child node and a parent node. It's as simple as that. So this is the system that we're looking to set up. Okay? Now, we have pretty much just said everything that you need to create this. So if you have yet to make your own command line interface, use this as an implementation plan, as an overview of how the system should work, and see if you can create it. Then come back and watch these other videos to see if your implementation matches our true implementation when we begin coding. Logan, is there anything else that you would like to add into this?
There's nothing I can think of. I mean, this is it. This is the design idea for how to make an object-oriented command processing system.
So we're looking at a whole bunch of classes. The nice thing is we've got a command class that we can simply put anything that is shared amongst all other commands in, such as a name, because a command is going to need a name, a command name itself. And that command name is what we can use to track down or create the relationship between the list and the commands. And, of course, our abstract process method as well, which is going to need to take in for, let me draw this up here. Let me find my pen real quick. It needs to take in an array, the arguments array, so don't forget that. But so we've got classes, and then, of course, all of this is going to reside in the command manager. Okay? So I just draw it just like this. So several different classes. We've already started the infrastructure back over inside of Visual Studio, and we'll simply build on that as we work our way through creating the entire command system. The nice thing is, later on, if we want to add more commands, it's very easy to do. We simply create a new class that represents that command, add the appropriate information into it, and then register that class over in the static commands list. That's it. So with that, let's go ahead and start building this thing. Once again, if you have not yet created yours, start. See if you can make something that matches ours. All right, well, we'll see you back in the next video where we'll get this whole thing kicked off. Thanks a lot.